Welcome. In this tutorial, we're going to be going over the REV onboard gyro. So it's relatively complicated to set up for the first time, so that's why in this one I'm going to just put in all the code first, and then I will go over it. Once again, this code will be in a GitHub, and this is a smaller version of, or a compressed version of this code, which is the template in FTC robot controller. So the first thing we're going to do up here is, you don't really say gyro sensor for this. It's a special component, and when declaring it, you're going to call it by this. This is what you're going to call it, and by default on your config file, it's going to name it as IMU if you're using a REV sensor, of course a REV hub, and that is needed. So now this is another variable you will need to set at the top because it is needed for the program to work. So just put those there. This is basically, it's important, this actually gets you the angles so that you can use. So now this right here is something you have to write before. Now you don't really need to put a config file. There is examples on that in the templates on config file, but the REV gyro is very accurate, and it barely ever needs. I have never had to use it for calibrate it, and it still works fine. So what's something you have to do is you have to pretty much add parameters to it so it knows what it's doing before you actually use it. So you're gonna have to run this piece of code. Basically what this is saying is just that it's making a new parameters object, and that it's setting the parameters of the angle unit to degrees. So then IMU gets hardware map. We write it in this form. I have not tested it in the other form, but this is the basic form and how you're going to be getting it accessing. That's the name. Should by default be IMU. Alright. Now we're going, before we start our program, we're going to initialize these parameters. So it actually knows it's using these parameters. So now in the program, I'm going to show you what kind of code I put. So one thing you have to do, whenever you want to use the gyro sensor's values, you need to run this code before it. And not like run it once and then we can do it forever. Every time you're accessing a heading value or a roll value, you need to redo this, or it's going to just get the ones from the last time. So what's happening here? We're using this variable. This basically just sets angular rotation orientation, so it knows what axis it's on. And now what we're going to be doing is adding this data to the screen. So the heading is 180 to negative 180. This is what we're going to be using a lot. It's basically the how far your robot's turned, and the way you do this is angles.first angle. That's how you get that. The less common use, but still there, is roll and pitch. Roll and pitch you would access with second angle and third angle. So most of the time you'll be using heading if you want to test a value or you want to move to a certain heading degree. Let's say you want to do a perfect 90-degree turn, chances are you'll be using heading. So that's pretty much the basic sense on what gyro is. It gives integer values, so when you're using angles at first angle, you can use that where you need it. Remember, this needs to be put. Let's say we're going over here, if angles dot first angle is greater than 100. Now this is going to be, now usually you don't want to thread sleep in a teleop program, but just for the sake of showing that this could be in a different position or angle by the time this sleep is done. And the thing is, it's just going to take this variable from there, and it's not going to be updated. So you need to run this code again to make sure it's all updated. So thanks for watching, and that's basically how to use the REV gyro. It's a little bit more complicated than a modern robotics gyro sensor, but it has its advantages since it's on board on the REV hub, and you don't have to worry about it as much. Thank you, and I'll see you in the next tutorial.